Dear students and participants on the course on railway engineering, today we are going to continue with the track junctions and their designs. If you remember, we started discussing about the track junctions in the previous lecture. We discussed about the various layouts wherein the classification was on the basis of the fracture, on the basis of a split. We talked about the double turnout. We also discussed about the crossover design, and then we calculated the various components of a crossover on the basis of different methods. In today's lecture, we will be discussing different other layouts which are possible on any of the track, where the two different tracks or the more tracks they are joining with each other. They can be diamond, slip, scissor, gauntlet, triangle, double junction, or the new types of designs which are in use now. They are the fan shaped layouts which are for high speed conditions. Let us start with the first layout, which is diamond. Now, this type of a junction is found when two straight tracks crosses each other. So, you can see here this is one track and then there is another track, and they are straight tracks, there is no curvature, they are just crossing each other. So, at this point a diamond shape crossing has got created, and this is the reason why the name is being given as a diamond track junction. So, in this photograph also you can identify that there is one track coming from this side, there is another track coming here, it goes in this direction and the other one is going here. In the center we have a diamond shaped arrangement, and that is why the name of this particular crossing is or junction is a diamond junction. Now, it consists of two acute angle crossings. So, there is a one acute angle crossing here, another acute angle crossing here. If in this diagram we see, then it will come here. Two obtuse crossings. So, a very big angle is going to be there here. Three pairs of the wing rails. So, the number of wing rails needs to be provided. So, where those wing rails will come. So, here in this form that will be there, say here also. So, the three pairs are going to be there and the four jack rails will be there. So, four jack rails means if on this side, here and in that form. The layout restricts the speed of movement and hence it should be avoided as far as possible. The flattest diamond which is permitted is 1 in 8.5 for broad gauge, or otherwise it has to be better than that. So, if we look at this structure or the arrangements, again let us refer the diagram which is being given on the right hand side. This is track 1, this is track 2, they are crossing each other and that is where the diamond has been formed. So, we have gauge, that means this is the distance between the two parallel rails here. Similarly, the gauge can be on this side which will be G. Now, A, D, C, B, that is the diamond, or you can say A, B, C, D. So, if you are looking at this rhombus, this diamond is being created. Here you have the jack rail provided on this side, once on that side, another here, another here. Then the wing rails, one here, one on this side and one in the center. So, there are different components which needs to be calculated. So, we need to calculate this AB or BC or AD or DC. We need to calculate this diagonal, that is AC, or there can be another diagonal which is BD. So, all of these things needs to be calculated so that in the field it can be set very easily. So, let us look at the first, that is EB is here, and this is DF. Okay. So, this is DF is equals to A into cot of alpha. So, DF is here and this is AE. So, EB. So, this is AE A into cot of alpha is the value which will be there. A is equals to G. So, it is G into cot alpha can also be written as N. So, this is Gn. Then AB, this one is AB and this becomes equals to BC on the basis of the property again, and this is nothing but when you are talking about this AB, this angle is alpha and this distance is known as G. So, it is G cosec alpha. Then diagonal AC, this diagonal AC, now the angle which is being given that will become half. So, this is alpha by 2 and here AC is nothing but the G value and the cosec of alpha by 2. Similarly, if we talk about this BD, so this will be G into sec alpha by 2, because in that case this is how we can calculate. This will be G, this angle again will be alpha by 2. The length of the gap at point B and D. So, here at this point as well as at this point it increases as the angle of crossing decreases. So, in general whenever any diamond crossing is being given, so these type of elements needs to be calculated. A longer gap increases the chance of deflection of the wheel towards wrong side, especially with smaller diameter wheels, and that is one of the issues with respect to these type of junctions. Now, what is the improvement in this particular junction or the design is that the provision of 25 mm higher check rails. So, the check rails have been placed at a higher level with respect to the lead rails, so that if any deflection is happening, it is not creating a problem in terms of say the derailment or the flange just going over the rail head. Then reduction in the check rail clearance by 3 mm in the case of obtuse crossing. So, if it is an obtuse crossing, then with respect to the check rails, then the clearance is reduced by 3 mm. Let us calculate certain values for the diamond crossing. We are being given two broad gauge tracks which are crossing each other. So, that is where we have the G value as 1.676 and the angle of crossing is given as here. The number of crossing is 1 in 12. So, on the basis of that we can find out the angle of crossing also. So, the formula is n is equals to cot alpha, n is known to us. So, on the basis of that the alpha is calculated, which is 4, 45, 49. We have to calculate the various dimensions of the diamond crossing here. So, that means AB, BC, CD, AD, then EB or DF or AC or BD. These are the different values which needs to be calculated for this diamond crossing. So, calculating this is EB is equals to DF. So, this is AE cot alpha or GN. So, G is 1.676, N is given as 12. So, we get a value as 20.112. So, this EB or this DF, this is 20.112. Then AB is equals to BC is equals to G cosec alpha. So, this AB is equals to BC we are talking. So, G is 1.676, alpha we have calculated, it comes out to 20.18. Then the diagonal AC, this is AE cos sec alpha by 2. So, this is 1.676 and cosec alpha by 2, we get AC as 40.33. So, this is also calculated, and similarly there is this BD, and this BD is related with the value of G here. So, G sec alpha by 2 and this comes out to be 1.677. So, it looks reasonable that this is 1.676, just a small difference is coming in this direction. Let us talk about the another case, the slip. Now, in the case of a diamond crossing, what we observed that if the train is coming from this direction, then it will keep going straight in this direction, or if a train is coming from here, then it will keep going in this direction, or vice versa. But there is no possibility that the train coming from this direction can take a turn here. This is not at all possible. Similarly, a train which is coming from this direction cannot go in this direction. So, as to solve it, the slip is the solution here. So, in the diamond, the track crosses each other, but the train from either of the track cannot change the track. The slips are provided to allow the vehicles to change the track, and these changes can be done depending on in which particular direction it needs to be done, whether it is to be done only in some single direction, then the single slip can be provided, which will allow a train on one track to move on the other train or vice versa, or if we require to do it for any of the directions, then in that case the double slip has to be provided. So, what is this slip? Let us look at that. So, in this diagram, so a slip rail has been shown here, but let us look in the other diagram where it may become more clearer. See, just see in this photograph, this track goes straight and this is another track which is going straight here. So, that is where the diamond is getting created. Now, if I am interested to move from this track 1 to track 2 and this track 2 goes here, this is 1. So, I am going from 1 to 2, a slip is being provided here. You can see there is a curved rail, this one is a curved rail. So, the train which is coming from here using this particular curved rail, which will be attached on the basis of the movement on the sliding bar. So, the train will move from 1 to 2. Similarly, if the train is coming from this 2 and it wants to go to 1, again another slip is provided here. That means now there is a possibility to go from 2 to 1. So, in this particular photograph, it means it is a double slip condition. It may happen that it can be a single slip condition also. So, arrangement consists of 2 acute angle crossings, 2 obtuse angle crossings, because it is a diamond crossing. So, that is going to remain there, 4 check rails and the special curved lead rails, 1 or 2 in number depending on whether we are going with a single slip condition or a double slip condition. Single slip consists of 2 pairs of switches, whereas the double slip will consist of 4 pair of switches. So, you are going straight or you are going on this direction, that means a switch is required here. Similarly, coming from the track 2, you are going straight or taking a turn, then there is another switches are required in this case. And this will happen from both the directions. So, here you can see this is a single slip condition where the movement is being allowed in this form, or the movement is allowed straight, but the movement in this direction is not being allowed. So, there is a single slip and that slip is A1 D1, A2 D2. If you look at the diagram which is given at the bottom, here the connectivity is provided between A1 and D1, and obviously for the same there will be A2 and D2. So, both the rails, both the lead rails have been connected here. So, this is one slip, whereas in the other case there is a movement like this. So, it is C2 B2 or C1 B1. So, this is a double slip condition. Here in this photograph again you can very clearly see this is 1, 2, 3 and 4. So, these 4 are being provided here. Then the next type of a design is a scissor crossover. So, it is a combination of 2 crossovers between 2 parallel tracks. We discussed in the previous lecture about a single crossover. We said that there is a track here, there is another track, parallel track here, and then we are providing a connectivity in this form. But then it was restricting the movement in a sense that if I am on a track 1 and this is track 2, I want to go from track 1 to track 2, it is not possible, but I can move. If suppose I am coming from the left hand side, then that is not possible, but if I am coming from the right hand side, then the movement is possible. Similarly, when I am on track 2, if I am coming from the left hand side, then the movement is possible to go to track 1, but if I am coming from the right hand side, then I cannot move to track 1. So, the solution here is this scissor crossover. So, you can see here that in different directions, this is a track 1, this is track 2. So, a system is being provided to connect on this side as well as the system is being provided to connect on the other side. So, we are connecting it in this form. Obviously, in the center a diamond is going to be created and there will be this crossing, there will be crossing here as well as here or on these positions. Now, this allows the train on either of the track to change the direction. So, it is an improvement over the single crossover design. It is provided at locations when providing two crossovers is not feasible due to the space restrictions. You cannot have that one crossover you have provided here. Okay, let us move forward and another crossover is provided in this form. So, then it will create a issue. It consists of the 4 pairs of points and switches, 6 acute angle crossings, 2 obtuse angle crossings, jack rails and the straight lines. So, these are the combinations, these are the things which will be available. You can check it out with respect to the design, that where the jack rails are provided, the wing rails are provided or the points are provided or the switches are provided, where the crossings have been provided with respect to the different angles. Now, this can be classified in 3 forms and the basis is the distance between the 2 parallel track and the positioning of the crossings, the turnout crossing and the main line crossings which will be there. Say in this photograph, you can see that the crossing is being provided here, but when the crossover is happening, that the crossover crossing is also here. So, they are more or less on the same location. And some other cases it may happen that it is at a different location. So, if we are talking here, so it is may happen that on the basis of the length, this and this they will get separated out. So, what is a type 1? Type 1 is the acute crossing of the diamond falls within the lead of the main line turnout. So, whatever is this acute angle crossing of this diamond is there, it is falling within the lead. So, when we say it is falling within the lead of the curve, that means it is coming even on this side. So, when it is coming on this side, then this is not a satisfactory arrangement. The second one is the acute crossing of the diamond falls opposite the crossing of the main line turn. So, the one which is being shown here, they are just facing each other. Now, this is also not a desirable because it is going to cause jolting of the wheels. Okay, so, it is just crossing here or at the same time here also there is a crossing. So, the jolting motion will be there. The third type is, in this case the acute crossing of the diamond, it falls outside the lead of the main line turnout. This is one of the satisfactory arrangement. That means, if we are talking in this form, so it starts from here and there is a this crossing being provided. Now, if it is a long one in this form, so this crossing comes here and this is here where the curve lead is stopped at this point. So, it is going out of the length. So, in this case the acute crossing of the diamond is far away from the crossing of the main line and as I said it is a satisfactory arrangement. The another type of track is a gauntlet track. Now, gauntlet track is a temporary diversion provided on a double line track where the double track is to be narrowed for a short distance. So, you are coming with the double line here, but now there is no space here. So, what we are probably doing is we are just going down in this form and then go straight and then again we can make it double. So, finally, this is going to, so there is a restricted area here and that is where the merging is being done, or the track is under the repair or the track is on the bridge and on the bridge one side is to be blocked because some major repair is going on. Now both the tracks they run together on the same sleepers, because once it has come here, then the sleepers which are provided they will be the same sleeper. There will not be two different sleepers, though here the sleepers were different. So they were coming on the different sets. This arrangement has two sets of crossings without any switches, and this is operated on the sections where the trends operate on the mix of gauges for the short distances. It may happen that the narrow gauge and the broad gauge they have been jointed together. So it may be a possibility that there is this broad gauge, but if you use this particular rail then set of rails, then this becomes a meter gauge. So meter gauge, narrow gauge, meter gauge, broad gauge, those combinations are possible, subjective, there is a requirement of doing that, but then this is being done for a shorter distances. What are the salient features here on the basis of this discussion? There are two tracks which are laid on the same sleepers. We do two sets of crossings and without switches. These can used even with the mixed gauges and it economizes the constriction. It can be used to economize the cost of the double line bridge. So instead of a double line bridge, we have a single line bridge and the connectivities have been provided beforehand as being shown here. So it may happen that this portion it is a bridge. So you can see here there is a broad gauge and there is a meter gauge, they are coming, they have been jointed together, there is a bridge at this location. So both of the tracks are just moving here. So only single bridge is required, the width of the bridge is being reduced by making a combination of that. In the other case there is a track under repair. So we have provided a diversion and this diversion is being used here so as to move the train in the same direction, but partly using the parallel track. Here with the one which I have drawn previously, so that is the thing which is shown, there is no switch here, the only crossing is there. So that is what was written there, that we have two crossings, but there are no switches being provided in this particular type of a layout. So there is no such a point of weakness which is there, which needs to be taken care of. Then the another type is the gathering line. So if you look here in the diagram, so there is a one track and from there different lines are coming out of it. So this type of a arrangement we are talking here. This is a gathering line in a section where number of parallel tracks they gather or they merge. So it can be said that it is merging here or otherwise it is just coming out of it. The number of parallel tracks can take off, that is another case, just enough reverse of it. Gathering line is defined by the turnout angle and the angle of inclination of the ladder track. So the turnout angle is there and what is the angle of inclination of this ladder track. These are the two things, they will define that what type of a system has been provided. Now because so many things are coming out of it, if you look at in the simpler form, it just gives you a feeling that these are ladders. You just put your feet on it and you will get towards the top. So that is the reason they are also known as ladder track. So based on the combination of the angle or the curvature at the turnout or the inclination at these particular locations where they are going out, taking off or merging, when the angle of inclination of the gathering line is same as that of the turnout, it is said that it is being laid on the angle of crossing. Okay, so in this case it is being laid on the angle of crossing at every location, it is angle alpha. The other one is the angle of ladder track is equal to the angle of crossing and the two tracks intersect at the T and C and no curve is introduced at the turnout crossing to connect the parallel tracks. So this can be the another type of a arrangement. The third is that the closure rail is used to the gap between the lag of the crossing and the turnout and the stock joint of the next turnout. So, this is related with the crossing angle conditions, the various points which can be there. Now, in the case of the limiting angle, when the angle of inclination of the gathering line is greater than the crossing angle, then we said that it is on the limiting angle. So, in this case what happens? A curve follows the back leg of the crossing. So, whatever is the back side of the crossing is there, the curve follows that. No gap is left between the stalk joint of the next turnout and the back leg of the crossing. The limiting angle is given by sin alpha is equals to S divided by L, where S is the spacing between the two parallel tracks and L is the overall length of the turnout. So, overall length of the turnout we can calculate on the basis of the various methods which we discussed in the turnout design. Now, gathering lines can also be laid at 2 to 3 times of the crossing angle. This type of arrangement is usually found in the marshalling yards, and that is known as balloon layout. Now, this layout is based on herringbone grid and it is used if the various sidings of the marshalling yards are of equal length. So, one of this is being shown here. Here these all lengths, they are of more or less same length. So, these tracks which are parallel here, so it is in the marshalling yard and these are defined as sidings, and these sidings are used for different reasons. They can be reception siding, there can be sorting siding, there can be a departing siding. So, reception means the train is being received on that siding, sorting means the train is being formed on that siding, and departing means once it is being formed, it is departed on the main line track. But then this is not a popular design. Now, let us talk about triangle. So, what is triangle? Triangle is mostly used in the terminal yards to change the direction of the engine or an unimportant section or where enough area is available. Now, why we say enough area is available? As you see here, there is a straight track and then there is a track going to the left, and then from that side another track is coming and merging into the straight track from the left side. So, as to do this on the basis of the curvature, you will require a lot of area to construct this type of a triangle. The name is because it is creating a triangle here. So, this happens either in the yards or it happens if there is a space available or on unimportant sections, because otherwise if the juggleries needs to be done here in terms of the movement or the directions, then it takes lot of time. This particular system has been found to be cheaper as compared to the turntable. Now, what is turntable? Now, there is a track and here a circular section is provided on which the track is going on, and it can go straight also. The engine will come, the locomotive will come on this and it will stand here. So, this is the front side. So, that is the front side here. Now, this turntable, this rotates. So, it will be rotated, and once it is rotated, then the direction of the locomotive will become this way and it will go back on the track. So, that is a turntable design. But this turntable design is costlier, and that is the reason the triangles were created. Now, what it consists of the two simple turnouts, say one here and one here, one symmetrical split. So, from this direction if you understand, so there is a split in this form with lead rails, jack rails, etc. So, you can see by yourself that there is a crossing here. So, wing rails will be there, there is a jack rail here, similarly a crossing, wing rails and jack rails on other side also. Now, in terms of the changing of the direction, what is happening? You are coming say from the P side, you want to change the direction of the locomotive. So, what you need to do? You have to go towards R. So, you are coming from this direction and that is the front side. So, you are going this way. So, now your direction will be in this form. So, you have come here. Now, you start returning from R and go to Q. So, when you do that, then this is how it will be coming. and then once you come to Q and you start coming back, then again if we look at the condition, then this is how it will be moving. So, now what we have done, we have changed the direction of the locomotive by using the triangle. Now, triangles initially they were used because we had steam locomotives, and the steam locomotives are not having a flexibility of moving in both the directions, wherein the pilot or the driver can see easily that what is happening ahead. Whereas in the case of electric or diesel locomotives, that flexibilities have been given and it can move in any of the direction, and there is a loco pilot sitting area and the control area being provided on either of the side of the locomotive. So, in those particular cases, now the triangle is not required because it can move in any direction. And that is the reason slowly now, because we are moving, we already moved from steam engines to diesel engines, and then from diesel to electric locomotives we are moving. So, these type of triangles now they are not required, and slowly the modifications are going on and they are being removed. Now, let us talk about the double junction. A double junction is this, a type of a junction is provided when there are two or more mainline tracks which are running parallel. So, here you can see in this photograph, there is one track here, there is another track here, they are the two parallel tracks, and the branch lines take off from these mainline tracks in the same direction. So, a branch line is coming here and then there is a branch line coming on the other side. So, this is a double junction case. So, there is one junction coming here and the junction going this way. It consists of one or more diamond crossings depending on the number of parallel tracks. The arrangement can also occur with the curved mainline tracks. It may happen that the mainline tracks are curved, and from there also further the curved tracks are coming out. Now, let us talk about the new designs which have come out. They are the fan shaped layout. This layout is designed for the concrete sleepers and is applicable for both right hand and left hand turnouts. The name is taken as fan shaped. Why it is being taken as fan shaped? Because of this type of an arrangement which is being shown in the right hand side diagram, where you can see that it gives you a feeling of a fan. The reason is because the slight less spacing on the inner rail and wider spacing on the outer rail and tilting of the sleepers in the lead portion gives a shape of a fan. So, you have less spacing on the inner rails there, whereas it keeps increasing on the outer rail. The salient features are, this layout enables the use of same sleeper for left hand and the right hand turnouts without making much of the changes. There is a slight lateral shifting, and with the help of that the same sleeper can be used. The sleepers in the switches and the crossing portions, they have the same orientation as designed. The sleeper are perpendicular to the main line in the switch and at right angles to the bisector of the crossings in the crossing portion. So, when you talk about this crossings, in this crossing it is at the bisector of the crossing. In the lead portion, the sleepers are laid at the bisector of the angle made between the perpendicular drawn from the main line and the tangent drawn at various points on the lead curve. So, there is a lead curve, and this lead curve, if you draw the tangents at different points, and then there is a angle between the perpendicular drawn from the main line. So, if this is a main line, so if you draw a perpendicular here, so that will give a value, and that is alpha by 2. The sleeper spacing measured along the straight track is slightly higher than measured on the lead curve. All PSC turnout sleepers for broad gauge, they are designed with the 60 kg per meter rail sections. Now, smaller rail sections can be used, but we need an additional thing in terms of the thicker liners. The slide chairs to accommodate different rail sections are provided with common hole spacing. So, that means in the same type of a slide chair, different sections can be adjusted easily. Only CMS crossings are used on the PSC sleepers layout. The gauge of the concrete sleepers were 1 in 12 broad gauge turnout. It is fixed as 1673 mm, just a small change is being done here. Now, here you can see that there are different type of turnouts. For those, the number of main sleepers, the number of special sleepers which are provided on the approaches to this type of a turnout, the number of sleepers on the exit side, and the total number of sleepers have been defined. So, in the case of 1 in 12, we have 83 main sleepers, there are 5 sleepers on the approaches, there are 4 on each side, that is total 8 sleepers on the exit side, and then total numbers is coming out to be 96. So, with this we close our discussion here on the various types of track junctions. We discussed about the diamond junction, the slips, the scissor junction, the gauntlet, the triangle, the double junctions. We also talked about the new types of track junctions which have been designed, which are named as a fan shaped layouts. The salient features of these fan shaped layouts were also discussed. So, we are now closing this lecture. Thank you, and we will be meeting in the next lecture.